this map field utility, how it work. Basically in this video it basically talk about the maps field using map field utility in OpenFOAM. It's map in the this utility it maps the field from one case to another case. Like if we have if we have some case, so that flow field we can use that, then the field variable values we can use for the another case. So also let's we will see in the later in this video when I demonstrate this case here. I have considered one problem which I am going to demonstrate by two different solvers in OpenFOAM. First, like two solvers which I am going to solve, that are simple form and pimple form. Basically these are two solvers. One solver like pimple form, it is basically it is used for this flow analysis, unsteady state and compressive flow analysis. And simple form solver in OpenFOAM, it is used for the steady state in compressive flow analysis. This map field utility, it is used to map to map the fields, as I said. And this work like initialize, like suppose we are going to some solve some problem, then we can initialize the field variable, but when we have some another case. Like we can see this like we can see in this demonstration. Now, like I said, we have considered one problem, so flow analysis. When we have the steady state simulation results, so then steady state simulation, then we can use for the tangent simulation. So I'm going to demonstrate here in two problem here, by using two solver here. So let's watch in more detail. So let me open the terminal now. So so just one second, please. So here in this demonstration, I'm using the this latest version of latest version of OpenFOAM, like OpenFOAM version 1206. So let me start how we can solve these two problems. See, just if you have any comments, or you can write in the chat. Well, I will later on I will reply to you. So as I said, I'm using here latest version of OpenFOAM. Yes. Now basically we will take the tutorial case, and we can take the tutorial case. Like, see, if you I have demonstrated how to work this run command, and this and we have this run command. Either we can use run command, or either we can use this environmental variable form dot run. This variable, this variable we can use, but it does both the same thing. So here now now I will copy a tutorial case into the run directory. cp just one second, cd cd just one second. These are the tutorial case paths. So like we can take this path like that. This is the tutorial path where my OpenFOAM is installed. Basically this OpenFOAM is installed in my this external hard drive. So let me go to into the run directory, cp -r, and then we can copy media. Then we can copy, this, we can take this path, media, yeah, oh, um, and tutorial incompressible. There is an incompressible and simple form and it easy. This tutorial we can copy the into the run directory. Yes, basically this is the, like we can say, the simple form. Basically this is the steady state. We can change the name is mb wait mb case simple form ls. We can see we have the one case is here, simple, this one case here, one case which we are using, which we are going to solve by using this simple form solver. Some another case, we have the transient. Like I said, we have the two case here. For the, we are going to solve same problem, one for the steady state, another case for this tangent, unsteady state. Let me see this first. Let me look. I'm not going to change anything, just cd and case. I'm just taking this this tutorial case. As you know, everyone, if you as we know, though, if you you know the where what we have the three directories, one for the system and zero, basically zero time directories, time directory, and this is the constant where we define the constant on the flow properties. And here there's some like we have the system directory. In this directory, basically this is the standard format of the any case, or in which we, when we solve this any problem in the OpenFOAM. So, and if you want to see the whole what is inside, then we can I can show this tree and minus L2. See, we can see what is the file inside this directory. In this case, like a zero directory, it has having this basically this is the turbulence case, and it had we are using the k epsilon omega here. All the file necessary file is in the zero time directory. And another and we have to define all the property of the transport properties in turbulence property in the constant folder. In this we have defined all the, basically this is the standard format. And see, basically this is a tutorial case which I'm just my motto to not to go in the detail. Just I will show the demos how we can use the this map field utility. Now let me see. Just I'm just like and this we have this like external, we have the this utility block mesh utility which create this, and which create this what mesh. If you want to see what is inside this blockman, then you can see, you can visualize, you can be block just one second. No, just we have to go cd system ba block mesh. You can see the mesh properties here, all the, and here we are not going to change. We will change all the default whatever is given, the boundary condition, what patch name is here, boundary condition, like boundary condition inlet outlet. We are not going to, all the same, both the cases are same. Just I am going to create this one. Now let's run side by side, run this case. And first what we need to do, first we have to create the block mesh. So the mesh is created, and and here, like I said, we are using this a simple form here for this problem. Then we can use this, we can run the solver, simple form solver. It will iterate the case, and we can see the later on. First sidewise I'm going to open this now, another case for the turbulent tangent case. This open for, like I said, we are using 2106 solver, this OpenFOAM version, and just now both runner command, it will work here. So like in one case we have this simple case, another case we have to copy form this pimple form. Let me copy this let me copy this case, media class, what is the program, that is the name of the my hard drive, my external hard drive program. So that OpenFOAM, it has OpenFOAM and OpenFOAM, no, OpenFOAM version 2.1, this one, and we have tutorial, then we have incompressible, then we have the pimple, this pimple form, then we have the here, in this case we have three, so we have to take turbulence case here, and same bit. So and we can copy into this our run directory, then we can see this the this case is copy, we have copied the tangent case. Now just mb it, so case, then pimple, we can change the name, pimple form. So let's see, now we have the two cases here, one is the simple form and another form the pimple form. So which pimple form, basically tangent simulation, tangent flow, and this is the steady state flow. So now like we have earlier we have seen this the steady state case. So steady state case simulation, so then we have this here, so that is done, right? So if you want to see this what inside ls, and let me visualize -l2, so no 2 is not needed, is 0 1. So let me see like in this already this case is done, they basically this are done. If you want to see this the results of this t paraform minus torch, and that is a dummy file, this is created, so this file is created, right? If you want to visualize these results, so let me visualize this visualize this result, paraview, and paraview case, that case and in background. So and this is the basically OpenFOAM, just we have to select this OpenFOAM case here. Let me see now. So basically this is the case, as we can see here, this is the velocity profile. This is the velocity profile, just let me just 1 second, let me go this one, and we can see here, if see how you can see this is the study, basically this is the velocity control plot here. Just one, let me just 1 second, state, and this is the velocity profile for this problem. When we here we have this computational domain, here the velocities come, we have defined the velocity here, and this is the outlet, and this front and back side. Yeah, basically the 2D problem. So like our motto is the different. So like we have here, this is the like if you want to see which iteration, like this the iteration, this is this this once this just 1 second, time filter, and basically this is the iteration, this is iteration, basic just one, let me just 3.3. This is the iteration, and then we can see how this velocity change and 0, and see we can see the what initially we don't have anything here. When the simulation at the time the simulation is processed, so we can see after 100 iteration the velocity profile like that, and after 2 iteration like this see. Okay, one case is this, so this is the steady state. Now like this is the basically this is iteration, the this profile, like this the field, this is the field of this field we can use for the transient case initially, like this one. Just let me now this for the this for the steady state case. Another case now another we have this the this is another case we have this this one tangent simulate tangent case, which we are going to use the pimple case. Let me go cd, let me go into the directory cd case pimple, and basically everything as you know the there's a standard format, nothing is changed now. If we now just one second, para home minus touch. See, this is the dummy file is created now, as you see here. If you want to see just one second, para view case, this for basically I'm running to the background. So as you can see here, initially initially we will not see anything here because we have no we have not because we have not created the mesh. That's what we are not able to show anything here. So first we have to go here there in this, and we have to run this what we have to run the block mesh. So the mesh so that the mesh is created. Now we can see now we can see the geometry. Basically we can see the now we can see the our this our geometry with mesh here. So at t time at 0 0 we can see here just let me at just one second just and just this is the case this is case initially, this is a tangent case basically. Thus initial we have not still we have not run the solver here. Just this is the initial case, initial condition. What is the problem here? Now as we can see here we don't have this we have this case this one case 0, and we have here this simulation steady state simulation. So up to that because as per this user specified condition at this whatever input we have given, so based on that this simulation is converged solution. So converge on this converge in to 80 iterations. So that field as we can see as this this field this we have the here all the fields. So this field we can use for this our for our tangent case. So now how we can that's why the map field utilities very useful. So now how we can use let me demonstrate now here. So we have note here, just one second, just I'll first we can time 3. Second. So this is the second thing. this is a tangent simulation basically now, because we don't have anything now. Okay, so let's see, nothing is changed, nothing changed, because we have not run the simulation, run the solver right now. Now let me save this state file first. Case ping, case ping now. Okay, and let me save, otherwise if case simple case. So now how now just now this one, in case now let me so now we are now is the important part, is important part. So like we are going to use map fields, this utility, just help map field help, map field help. It will it will display all the function how it work. So there are the some like we have to define map, if we are using this, we have to use the map fields and options. Options, what are the options are there? So they are the, these are the, so basically these are the various options for right now, for the timing, because we have the limited time to demonstrate and so we will I will go, because here as we can see, as we have seen, we have considered all the same case where the boundary condition and geometry are the same, so are identical, basically both the geometry and identical. So then and the so identical, so for that we are using this this option, and we have seen here and then we have seen here, just one second. We have seen here we have the two case, this is the statistical case. So like 0 directory and 180 iteration, 100 iteration, and this one 280 iteration. Basically this case is converted in the 280 iteration, so that is the 280 iteration. The map the flow field we can use to map for the this our this case. So how we can use, let me just let me show as we can see here. So see, nothing is changed here, like we have this case, nothing is changed, only this is a we have not run the solver right now till now, and we because we and only the 0 initially initially, and this is the flow field. Now at 0 time, see, because we have not done anything, just and so it's 0 basically. At 0 time nothing is changed. Now when we are now I'm going to use this map fill utility. Now how will use, how we can use this now for this tangent case. Now this is the pimple form we are using here for this case. This is a basically tangent simulation which I showed this now how we are going to use this, and just take map fields minus that this consistent, and we have done the this consistent, and we have seen here this is the latest basically latest latest time directly, but here the like this case is the steady state, so we save the latest iteration is this one 280. So this 280 iteration mean latest thing, so that we have seen this is the latest source. What is the time we are going to use, which source which field we are going to use, so that is the, so that we have to select that source time, and what it is, source time is the latest, let's say latest for the study 280 latest time, and latest time we have used this, and what is the, so now we have to sign which where we are in this case, then we are going to use the map flow field in the different, that's simple. Then we go back to one step ahead, one step back. So then that is the simple form case. So that is the source where we are going to do. Just we can enter now. Now we can see here, you can see this the source time, basically that time which map. Now we can see here. Now if you want to see this is what happened now. Now as we have seen the here, nothing is changed, right? Initially it's 0 time when we have not yet run the solver, tangent solver pimple form yet. So just just now you can see what you can now see 0. As you can see now at zero time initially we have mapped the flow field which already we have done. Basically, like if you want if you want to do this initial, basically this is a simple case. So if let's assume suppose it's a complex problem, then complex problem that it will take so much time to iterate, so much time to flow develop. So basically it will take more computation, and we have to if you want to reduce this computational time, then we can do some steady state simulation, then steady state value, then map field that we can use in the tangent simulation basically here. So now you can see this is the initial condition, like initial we have mapped the flow variable initially see. So nothing is said. Now question, now suppose now we have mapped this flow fields. So that utility is work that utility does it does the does this maps the fields. So now if now let me see, I also so cd and the system, then we can see the control file is there. So you can see now we are using this pimple form solver here, and we are going to solve this is basically default case. You can find in the mostly all the so open form version. See, no, now yes, now mass is done, and map flow map the fields variable also, map the flow field also map. Now we have to run the solver simple form, not simple pimple form. Basically this is a pimple form. And if you want to store the iteration, then we can use this log dot pim, pimple, whatever you want to, you can give the name. Then this, so basically oh, I did mistake. Basically it's running in the background. I forgot the run, I forgot to put this this and sign here. So if you want to see this here, let me just let me show this one. This, as you can see, the simulation is running. If you want to see what's going on, this is 10 minus 20 log this file. You can see this the iteration is still this is still happening. Yeah, so yeah, simulation is done. So the simulation is done for 0.3 seconds, 0.3 second. Now 0.3 second. Now if you want to see this result, see here, where this one. Now we have to now, like I said, we have used this we have used the initially basically if we run the simulation for the more time, then we can see the difference here. Now if you want to see the compare, if you want to see the compare, just let me show, just 1 second. This case, another case also here, this open one to get just 1 second. Pimple simple case all file are here. This case, OpenFOAM case, yes, and we can just once again just let me 0 this, basically this, yes, you can see here we don't require this right now, we are just, and this time, and we require this is the iteration. Just once again, this is iteration. Here are the iteration points. 1, 3, 0. This is the iteration. So if you go there beyond this, because that simulation, tangent simulation up to here, right, up to here, and this represent a number of iteration. So this is the basically this iteration, this if you want to see this all kind of this result, then we have this together. So just one second, this case, this nothing is just because they have the different scale here, so we have to suppose is 280 10. We have to multiply some numbers, so that is clear. I don't remember actually. So basically we can we can see the simulation, this one up to 3 seconds we have seen the 3D simulation. And if you just once again, basically this is taking this the same values here, because we don't have we don't have the tangent simulation for the 100 second. We have the tangent simulation for this. We have to if we want to compare, see this, just what I'll do, just I'll finish, just one second, I'll do the one thing. There is OpenFOAM. This one OpenFOAM version is this this one, and we have this simple case. So we can remove this, and this case, yes, and we can see this is a 0, and see we can see that this is 0 comma this, yes. Now see, let me just what because 0, yeah, 0 only. I have changed this. You yeah, basically here nothing is changed, we can see here. Basically if we run the simulation for this more time, then we can see the difference. You can see the different change, some change for this this time. So let me just play continuously. You can see it is the basically static simulation, nothing changed, but here you can see the some changes here, the velocity changing, right? Initially we have taken this this flow variable, flow field variable values, then we have a map for this our tangent simulation, and then we run the this whole tangent solver pimple form. So as time evaluation, like time 0.3, yeah, this simulation only 0.3. If we have the more, then we can see the, but still you can see the result difference here. So that like velocity profile changing. So that is the motto to demonstrate this this case today is here. So if you have anything, if you want to know, if you want to ask me for from me to demonstrate some more command how as well. So as earlier I have made some video for the few like form log, how it's work, and another how we can create the OpenFOAM template case. Then we have the form new apps command. So that kind, if you want to know. And this case, basically this is I have this map field map flow or map fields utility is work in a different way. We have the another, because if I consider like now initial in this case I have demonstrated only this when we have the same mesh, right? Same mesh in the both cases, and boundary conditions are same. That's only then what then what we have did here, that we have the steady state simulation for this same problem. Then we have used these results for this initially for the tangent case. Basically suppose up to this flow, when the flow is developed till this, so if we are using this tangent simulation, it will take so much time to develop the flow like that. So that's what we have done some initial case, some case for the some study for the this steady state flow analysis. So then this result we can use for the turbine, so we can save the computational time and time. So and also we can do that when we have the different what we map when we have the different mesh. Then and if you I have planned for one more video for this. Then when in that case we can see the different two different grid, like one grid is a coarse grid and another is a finer grid. So in that we can use this map fields utility. So based on that we have the another, and there are so many I have considered this. Just let me just 1 second. Like map fields help this, like there are so many options are available here. When we have this, when we have the different a different case, specific case, so we can use this like this and here, because we as initially we said we have the target geometry and boundary conditions are same, so that's what we use this. So there are so many options are available here. So but in one video or one demonstration we can we can demonstrate all options together. So one by one we can look, we can see. If you want to if you want if you want from me, so I will make the separate videos for this case. So guys, today's only I have this much. Yeah, thank you for watching this.